Okay, dude, I just recorded a whole video and then realized, like, even though it was telling me, like, the camera's not being used for some time, like 4 or 5 times, I finally realized, dude, I haven't been recording at all. So, anyway, we're talking about energy space and how all of this is a holistic combination, right? A holistic combination. So the mass and the gravity and the energy space are all connected together as part of the same object, the same moving object. Now, when we apply energy to the system, then that goes in this direction and it expands space. We were trying to figure out what kind of energy would go in this direction and shrink space down into the MC square to create matter. When it expands space, it also gives us phase transitions. I'm just going by what I'm seeing on the screen here. And that goes from solids to liquids that just start to orbit around each other to gases from expanding space, right? And that's just one type of energy, thermal energy. And if they shrink down, then that expanding space will emit photons, right? So when we're talking about wavelength by volume, we have wavelengths of different, like, so this is a 4 wavelength, right? And this is a 1 wavelength, right? 1, 2, 3, 4. A 4 wavelength is much longer, and a one wavelength is much shorter. So it's the inverse of frequency. Like, this is higher frequency, right? So this has a frequency 4 and this has a frequency 1 if the time was this bar. Now, but we're talking about what we want to do or how we want to shrink space to create mass, like we did with plutonium and things that we've already done. And so generally speaking, this holistic body of some shrunken space, and this is space-time, right? So it's volume. This entire 4 here is the volume, I think, and then the wavelength is 4 at each spot in this volume, right? And so that expands. I'm not sure, maybe volume should be squared, but I think that R squared is here and here, and that puts it together just fine. But it's the wavelength in these volumes, and so it's wavelength. Anyway, I'm not going to change what I did here. Now, when we're talking about warp space, like, and we have cosmic microwave background radiation, then let's say that wavelength by volume is like 10, and it's like 10 all throughout the rest of the universe, right? And that this doesn't just stop at 4 and then all of a sudden end, but it shrinks down. It goes 4, 5, 6, 7, 8, 9, 10, and then that's where space-time flattens out from the object. So this energy space still has wavelength by volume, even if it's just cosmic microwave background radiation, right? Even if it's 10, it still has wavelength by volume. And as we move across it with our speed, then that it interacts, right? So it interacts by speed, and this causes these wavelengths to start to shrink as we move over them, right? So 9, 8, 7, 6, 5, 4, 3, 2, 1, and if we get, and that gives us the warp bubble here, right, to maintain our speed in the first law of motion, right? So we have some speed that we've given it in space, and it's going to continue going that speed because a warp bubble is created over the background energy space just as a result of motion. Now, for the backside, if it's an 8 here and the background is just a 10, right? A 10 wavelength by volume. If the background is a 10 and we're moving in this direction at a speed of 2, and then this goes to 8, right? Then the back would expand at the same time to 12, right? and that's the natural warp drive, and we've also created plutonium and all kinds of other elements out of that. So this is, you know, and nuclear bombs and stuff. So this is just a shrinking of that energy space, wavelength, and volume, and its potential and kinetic energy when we're dealing with a nuclear bomb, right? So the